got, are both your knees pretty much ready to go?
Yeah, especially that.
Yeah.
Still walk pretty well level, but can't do anything up in the steps,
Right,
except one step.
yeah, right. Yeah. One step, one leg at a time, right? Yeah. Well, you know, the class of painter, you have to decide how you're gonna get to where you're going.
Yeah, I've actually scouted out.
Because almost every place in painter is involves stairs, unless you go down the ramp.
Oh, is there any place you go?
If you,
Yeah, I'm not gonna teach you.
yeah, if you go down the ramp, just before you get to the entrance on the physics department's house, that ramp takes you down to the first floor,
Oh, I see.
and then you can take the elevator up.
I see.
I'm not quite that far yet.
Not too many steps, I guess.
Good morning, everyone. Thank you all for coming this morning. I want to get started right away so that I can respect your time and get us out of here. Time for lunch. My name is Sasha Kopp, and I'm glad to have you all here this morning. I wanted to, in the next few weeks, present to you some of the resources that the college has been preparing for faculty as they think about other ways to work on their classes. And for myself, I would like to maybe start this by talking a little bit about the kinds of teaching models that at least I'm familiar with that might benefit from using this. And I asked Cynthia LeBrake from the Department of Chemistry to come in and talk to us about one of the classes that she has been working on, and I'll talk to us a little bit about the class that I've been working on, or a couple of classes I've worked on. And that's not to say that that's the unique solution to all teaching in the college, but merely to help us wrap our heads around various models that might make use of some of the resources that the college has been developing in Quest, and also in the area of assessment and using Mathematica, and also in videotaping some of our lecture content. So in the next couple of weeks, Cynthia and I will be talking this week about the courses that we've been working on and how we make use of some of these resources used by or developed by the college. And then next week, a couple of our postdocs on the Quest team will talk a little bit about the videography and capturing of lecture content that you might consider using as resources here at the college. And then the week following, another one of our postdocs will talk about how to write assessment questions using Mathematica, because I think many of us who have experience with Quest are prone to think of it as a multiple choice question bank, which I think up till relatively recently is a good reflection of what it was. But we've tried to flesh out the kinds of questions that you can put into it. And I know that some of the challenges I've been wanting to give the Quest team is how can I literally get to the point where I can use Quest to have, or can I use Quest to grade an assignment that looks like derive an expression for the following thing, and get back to that kind of hand-graded homework that we can't afford to do because we don't have enough TAs in the college to do all that kind of grading for thousands and thousands of students. So, you know, that would be sort of the pie in the sky. But I'd like to at least think about ways to use Mathematica for a little bit of kind of problem solving that we're capable of doing right now with the multiple choice question games. So I thought I'd talk a little bit first about some of the classes I've taught. I've taught senior level quantum mechanics here in the college. I've taught ostensibly freshman physics, but mostly taken by our pre-meds. I've done some sophomore modern physics classes taken by engineers and by physics majors. And across all these varieties of classes, I would find myself carefully preparing a summary of what they should know. And since physics is a fairly mathematics-intensive subject, I'd write out careful derivations of where all these important equations come from. And I do a couple example problems and show how to solve a problem using those important equations. And then I go give the students a question on a homework and expect them to come back a week later having the capability of solving that homework. And in preparing for lecture each day, I would probably look at the textbook a little bit, but I would have assigned them some reading to do. And I would probably have consulted some other texts and probably try to look smart by having a completely different derivation from the textbook that they read by copying out a derivation from some other textbook. Oh wait, that's the secret. I'm sorry. I'm not supposed to say that. But I remember one time someone made me aware of a tool in physics called the Force Concept Inventory. It was written by a group at Arizona State, I believe. And it had some basic questions, which to the physicists here in the crowd will look very familiar. And we were encouraged as instructors to give this assessment at the beginning of our semester and at the end of our semester. And this assessment doesn't consist of anything particularly calculational, or it doesn't require a genius level of calculus to do anything. You know, question 25 down there just refers to that picture, and it says if you've got this bead shooting through a little tube that's round, where does the bead go when it comes shooting out of the tube? And all the students have to do is pick the correct trajectory of those 5 choices. And it was interesting to note at the beginning of the semester that the students would randomly have selected any one of the 5 choices with basically equal probability. And at the end of the semester, I'm happy to report that they chose each of the 5 choices with equal probability. Despite the fact that this represents a problem which is, in a fairly basic sense, a centripetal motion problem in physics, and all of us instructors dutifully cover it in our class. We derive why it's so that Newton's second law of motion requires an object to move in a circle requires a centripetal force. An object without such a centripetal force keeps moving in a straight line. So the correct answer is B, for those of you wondering. You do remember something like that, yeah. I was further ashamed to see that actually, although the students did slightly better than guessing on this assessment before taking my class, they did only 1 point better on this assessment after taking my class. So there were some rather notable failures on the semester, and you kind of wonder, why did they take my class? But they clearly did do something in the class. They learned to do lots and lots of calculations, and they learned to do them correctly to the next digit on exams. But there are some basic things that at least all of us physicists would feel like were important that they failed to grasp. And I guess for me it was the first encounter with the idea of, okay, there's some goals that I would like to have in the class, and maybe without necessarily wanting to teach the test, I'd like to at least structure my class such that the students would meet a certain goal. I am happy to say that I'm not alone in this experience. There are published journal articles about the Force Concept Inventory and about how many classes actually result in negative progress on this, in this assessment. It's actually a pretty good assessment. It has a pretty good understanding of what should be in a first-year mechanics class in physics. But I think it's because so few of us structure our classes around learning outcomes that we end up not really achieving the kinds of things that implicitly we would hope for in a class. And I began to wonder, okay, so is it the case that in my class I should somehow structure the time to look at these conceptual problems better, or should I be spending the time doing all these derivations and mathematically intensive things? Because the instructors who follow me in a sophomore physics class would really rely on students being able to solve complex integrals and being able to apply them to richer problems, even more complicated than what we should be doing in a first-year physics class. So it's not the case that I want to set this the calculus-heavy physics aside in order to do these kind of conceptual things, because that is a skill that is ultimately required. But I then think about some other things that I've heard many people say, and David Lally in our college talks about this often. Instructors have a pair of roles in teaching a class. They have this sort of delivery of content kind of role, and they have this role as mentor and facilitator, and that's another role to be thinking about. And I thought, maybe in more crude terms than David has articulated it, that we have some things that we can do outside of class and some things that we can do inside of class. And for me, my personal introduction to this kind of topic came from the following textbook, which is, again, a physics book, so it's maybe not one that translates to all subjects, but it's written by Eric Mazur at Harvard, and it's called Peer Instruction. And the thing I like about this book as a model that's maybe generally approachable for all of our science classes, and he wrote this book before the web, so, well, not before the web, but before we use the web as much as we do now, so it has these great things called floppy disks. I keep them in here, they're still taped in there. So for those of you too young to know, before computers, no. In the early days of computers, you would stick this thing in your computer and it had had data on it, as much as kilobytes apparently. Yeah, so this is for thumb drives and email. In any case, Eric's proposed model for a class that he developed throughout the 90s and then wrote about in this book was one in which he was trying to do more active engagement in the class and try to think of himself as more this facilitator and coach in the class and relegate the content delivery to outside of class. And again, because this is almost before the web, he very much relied on textbooks as his model, but he had some very good ideas that if we're trying to teach students how to read textbooks and how to really assimilate the information from a textbook, let's really drive that skill into them. And he would begin every class with something he called a quiz, if we still have those in class. But he had these conceptual quizzes, and to give you a sense, let me just pick one up here. So this would be what a quiz would look like in one of Eric's classes, and you notice, they're not like, again, big calculationally intensive things. They are meant to assess whether or not the student read the book, which is, an achievement. Those of us who know our students don't read the book would wonder if, it's a good exercise or not. But they are really simple questions to access, were they reading the book, were they thinking about the implications of what they read? Not necessarily are they proficient yet at doing anything in the chapter for that particular concept, but rather do they appreciate what the chapter was about? Because they're not really ready to engage in class yet if they haven't even assessed, we know what friction is, or we know what the word impulse means, or it was in the book or not. So I think he was trying to do very basic things. And at the time I was starting to teach here in the College of Natural Sciences, Quest existed, and I could input some problems, and in fact I tried to do something one step better than Eric Mazur. I tried to collect all this data online through Quest, and then I would walk into class knowing that exactly 0% of the students understood that first question, or 20% of the students understood the second question. And I could base my lecture that day a little bit more on what I knew were to be the problems that they could not understand, or the questions they could not understand. But Eric took this model one step further. He actually had a big lecture hall available to him, like at Harvard, like we have here, and he would try to have the students solve problems in class. Again, not really calculationally intensive problems, but he would rather lecture a little bit, like we often do, for a few minutes, and then he would ask the students a question and ask them to work in groups. And it would be very noisy throughout the room, and you hear students talking to each other about the question posed. And I'll just show you some of them. They're not again, elaborate questions. Sorry, I'm one of those teachers that's now teaching straight out of the book by putting on a document camera. I think I'm not supposed to do that. A little bit. I have old eyes. This just represents the kind of thing that he would ask as a discussion problem in the midst of class. So this one is a word problem that's describing what a person's doing, and then they're supposed to be moving along a number line, and the question ultimately is which of the graphs below correctly describes or represents the motion described in that word problem. So it's trying to make the students proficient at the idea of graphing and displaying some motion in physics, because there's really no moving on from physics class until you at least understand how to do that. We can't take derivatives of things and expect them to integrate things without some basic understanding what the graph represents. Yes, Al?
Sasha, I suppose this is semi-relevant at this point. Every question you've shown us is what is of the form I will call what, okay? Which of these is right? What is the force? Which direction does the particle move? Stuff like that.
In the sense that it's a multiple choice question.
Not just that, but there's no why, okay? In
Absolutely.
particular, for that first motion problem, the circular motion, if somebody had been forced to answer the question why, they might have gone back and changed what.
Absolutely.
Because there would be no explanation for, all these curve motions.
Absolutely.
Okay.
Alan, so I'm glad you brought this up. I certainly
Okay.
will not be the best practitioner that you can talk to about how to use this kind of model for a classroom. I think some of the really great practitioners I'm familiar with in the physics department are people like Greg Sitz or Mike Downer. They love this book, and they would go on at length with you about how to use it. But I found myself able to use questions like this as the launch point for the discussions that would happen in class and then could address the why.
Gotcha.
So one of the more effective moments I could see, and literally I would watch Greg Sitz's class, you would pose a question like this to the students. They would vigorously discuss it for 3 or 4 minutes. You might have yourself walk around the auditorium as they're discussing it. I actually also employed undergraduate teaching assistants to walk around the auditorium while they were discussing it to seed some ideas out there. And then I would ask students for their ideas on what the correct solution is. And the best case is when there's not consensus. And you ask the student groups to explain why they would answer this, and you absolutely don't want to reveal the answer. You would like them to discuss it. And it allows you, the instructor, to then come in and add some perspective on how to approach the problem, or why it is so that, and you can then give them a mini lecture. So in the case of a little centripetal motion problem, I can remind students of, well, they read in the book that this mathematical derivation is so, and there's this box formula that they're supposed to remember, and this is how we apply that box formula in solving a problem like this very conceptual problem. So I have found this kind of question and answer type setting a very effective point for me to launch into an extemporaneous lecture, rather than just pre-prepare a lecture that they may or may not know answers to or know how to use. And it's a way of building a lecture on the fly that responds to where the students are at. Okay?
Thank you.
But I think it's great that you brought that up, because I probably haven't said this yet, but it has a certain dynamic quality of how to use the class time.
Good.
So I did this a lot in my classes, and as an instructional model, I found it really felt satisfying to me of the kind of things I could do in class that made my value added beyond the textbook, beyond just opening up the pages and say, this was on page 5, and here's the derivation of page 6, and then here's page 7. I've never been as proficient a lecturer as some of our really gifted orators who can start at the left-hand side of the blackboard and work their way to the right-hand side of the blackboard and have these nice, beautifully written equations. But this kind of style of teaching I found to be really effective, and it allows the students to get involved in problem solving, admittedly at a very basic level, but this kind of basic level problem solving, at least in the classes I've been responsible for teaching, is an absolute precursor to doing the more complex problem solving that we really request of the students by the time they have to get to homeworks. But I will tell you that the students in my classes really complained. They felt that the classroom should have been a lecture. They should have been given a summary of all the things that they were supposed to know, and they felt that the problem solving never got to the level of complexity that they themselves were ultimately responsible for, and they felt that there was no one place that summarized all the things and all the skills that they were supposed to have mastered by the end of the class or the end of where the test was supposed to be. Now, politely, I was trying to find a way to say that is called the textbook, but I don't know how to do that, and I never had the mechanism to force them to read the textbook, or I never had the mechanism in class to teach them the skills and how to use the textbook. Because I think one of the things that we all share as faculty is we evidently managed to succeed in classes where this was the teaching model, and we managed to figure out ways for ourselves to dissect a textbook, to dissect every single paragraph and not allow ourselves to move on until we knew what was the impact of that paragraph, or how we could derive that equation, or better yet, how to solve the little sidebar example problems that use that equation. We have those skills, and nothing in my classes, at least, really address how to get that textbook reading skill imparted to the students. And then someone finally explained to me that there's this thing called the World Wide Web, and no one reads textbooks anymore anyway. And there's this very nice YouTube video where people sort of assembled statistics on how many pages of textbooks an average college student reads, but how many web pages or emails a college student reads. It's many more of that latter category than there is a textbook category. And that's not a disparaging comment, that's just a fact of life.
So in fact, if we assign a web page for the course, or web sections for the course, it might be more effective for people to,
Well, funny you should say. So, and
or they have the same problem.
well, let's see. In no way do I mean to represent that the kind of things I'm going to talk to you about are unique. In fact, I feel like I've stolen anything as an idea here that I'm about to say. But I attempted to do basically heard what you just suggested. So this is a web page for a class that I did. This is basically pre-med physics for, and each of these links is a section of a 2-semester course. Not all of them are live yet because I never did finish all of this stuff. But the idea would be if I could sit in a quiet place and then do all those derivations or do all those example problems or do all those explanations of how things fit together, that would be kind of like the online textbook. And it would be a real lecture in the sense of it's a video of something rather than please go read something. And what this web page represented then was, let's see, well, here's a bunch of stuff on projectile motion. That's the typical starting point for a physics course because I'm a physicist, so I'm only going to talk about physics courses. But everything consisted of, a video. And these are none of them very long. I just want to find out where that one's 7 minutes, so I won't play it. But I'm sitting there with a little document camera and my pieces of paper and a Sharpie pen, and I'm going to do all the derivations that you would normally think about in a kinematic section of a physics class. And because I have the time and I'm not in a rush, I'm probably not going to make as many mistakes. In fact, I probably tell my students I usually make 50% of mistakes for every line that I write on chalkboard, but here at least I can make sure I get it right. And I try to do all those derivations, and at least I have a repository of all the things that the students were complaining that I was not doing in the active engagement type class. And I tried to work into this set of web pages some example problems. So I even did videos with examples. That's actually an Erich Mazur problem, which I won't go through, but I actually tried to reason my way through how to solve one of those conceptual problems that Erich Mazur did in his book. And I tried to make, literally, I took all the lecture notes I ever assembled for the class that I taught, and I made sure I did little video clips associated with every page of those lecture notes. And so it's a lot of little video clips. This is just a couple week section of the, or a 1 week section of the class. There's probably 20 little video clips there. And then when I walk into the real class, I have the opportunity to fart around in a lot of other ways that I wouldn't have been able to do because I would have been so worried about making sure I got through all the derivations or sample problems that I knew I was supposed to do. But this is still a very flat model. It's a beaming out of information. There's no way for me to collect much from the students. And so what I came to learn about from some of the college folks is that there are better tools available for doing something like this. I will just say it's not unique to introductory level classes. I did it with a sophomore class, and I was able to write little videos on everything about how to derive Schrödinger's equation and how to use it in solving problems and so on. So I don't think it's a model that's restricted to lower division classes because all the content is easier. I think we just have to think about what are all the things we would put in an upper division class and start piecing it into a lot smaller chunks so that we make sure that the students are aware of that this is a finite topic within even our upper division classes. I think that's still a reasonable model.
Sasha?
Yeah.
Once again, how do you use that right there? Is a student supposed to, do we expect the student has looked at all those things prior to your class so you don't cover that sort of stuff in your class? Or?
So yeah, my personal model, and again, this is not like I can profess that everyone should do this. I assigned typically 3 of those little video clips in a typical evening. And then because that was all the derivations and long form answer to things, I would start the class with a short quiz. And actually, I then later stopped doing that, and I did something that Mike Starberg taught me. which was he started every class with the students asking him 2 questions. I always thought that was a great idea. So that they all wrote down on a piece of paper 2 questions, and that counted as a little quiz. And so I would collect all those questions, and I would try to shuffle them quickly in order to what I thought was going to be the right presentation for the day, but I would try to construct some answers to the questions on the fly, because, you know, I've lectured on this before, I sort of know how to do it. But I would at least go at some of the things that they were not able to understand based on these video clips. And then, because that would only take probably a half an hour in the class, I would try to end the class with, in my case, this is an experimental field, so I would try to go through some key experiments in history that really exemplify the topic or give us our physical reason that we know that that concept of wave-particle duality or something is true. And that, I felt like, again, that exploited my value added as an instructor, because I know something about experimental physics and I know something about the foundations of quantum mechanics, and I can say a little bit why this is not just something printed in a textbook, but rather there are real live experiments that embody that idea.
Yeah. Are there any assessments built into the online or in-class do you collect?
In this way of doing it, no, there really aren't. I did put some sample problems, and the students were free to go work them, but I had no way of collecting any of that information. So this is where I have to stop and say, okay, there's no feedback in this process, right? So, as you know well, Sana, because you were involved in the development of some of the things in Quest, as were, you know, Shane and John Gilbert and many others, John Markert, that kind of feedback can be really useful. So, the kinds of things that I wanted to learn to exploit myself, and I still consider myself a student of this process. I really can't say as I am an expert in any way, but I tried to take all of these things that I had been doing and embed them into Quest. And so my temporary euphoria, because I will have to see how this really goes, but I'm very pleased that I can use some of that teaching model I've been wanting to do all this time and actually then build in the feedback and assessment. So this is literally the same introductory physics class. A few of us this summer were teaching an MCAT prep course, and Ruth was joining me in that suffering. I did my physics stuff this way, and I didn't really cover any of this in the MCAT prep course because I only had 6 days to do all the physics. So I made available to them all those lecture videos, and each of these things now or now go by the name of learning modules in Quest, but each of those video clips is tied to some assessment, and if I, as an instructor, wanted to, I could pull down the data of how successful were the students at mastering the assessments in that video clip. But for me personally, I was trying to build in that Eric Mazur model and try to do these conceptual questions first and then build up over the course of a learning module. So these learning modules, for those of you who have not seen them, let me just first of all say a little bit about what the architecture of a classroom in Quest now looks like. You as the instructor are able to generate a little syllabus like this, and so you can set up these kind of chapter headings for your class. If you have a 15-week class, these could each be the 15-week topics. I don't know how you want to do it, or maybe you'd say, I have a 15-week class and there are 5 major things that are important in your class. There might be 5 big bullets like this. However you want to do it. And then, if we think of that as like an outline, that might be like my Roman numerals, I guess, and then my subheadings. Well, let's see, let's do kinematics, because I was telling you that before. There are prepared here 4 little learning modules in that particular Roman numeral, and it's ended with a homework. Okay, so that's the old-fashioned, I want the students to calculate a whole lot of stuff now. Okay, but all of this will be now in Quest, and so let's look at what a learning module looks like. This isn't quite the student view, this is the instructor view, but I want to show you the instructor view first. The students will see a multi-slide presentation, kind of like when you go to do your online compliance training at the university, and you have to kind of click through a whole bunch of slides and then answer some questions, and you keep answering A and B and then C until you get the right answer. That's kind of what the students see, although you have to make it a little bit more lively. The students see, in this case, a 16-slide presentation. And some of these slides are me lecturing, so there could be a little video clip embedded in there, and they're supposed to watch that. And then some of these slides are actual assessment questions. So this one, for example, is an assessment question. And I know that because under question, it's got the heading in Quest. All the Quest questions have names associated with them, which are usually inscrutable, but some of them almost make sense. This is something about acceleration. In any case, so there are kind of a succession of video clip and then assessment and then video clip and then assessment, and it keeps on going. And I don't need to show you the video clips because they're not that cool. It's me talking. But the questions are very much of the nature of those kind of Eric Mazur conceptual. Did you understand what I just explained? Could you apply it in the most rudimentary fashion? And the other tool I haven't had yet the chance to really play with, but exists in Quest, is in principle, this is a little multiple choice question, Alan. It's not a why, it's a what. But there is a correct answer, and if it's a multiple choice thing, there are also 4 incorrect answers. And the utility now exists in the Quest platform to, let's say, B is the correct answer, but A is a meaningfully incorrect answer. In other words, it's a so-called distractor. If the student answers A, they really failed in a certain fashion to understand what I just did. And you could, as an instructor, program a little decision tree. I think that's what you computer scientists call it,
Yep.
Of where the student should be directed subsequently, depending on which incorrect answer they got. So if they were correct, they keep on going down this progression. But if they were incorrect, maybe they get directed over to, well, let's suppose they are just completely incapable of remembering what a function is. I could actually direct them over to a little learning module from Elizabeth Stepp in the math department on functions and precalculus, or something that I think would help remediate the situation. Or I could direct them over to another little learning module that I would write on how to apply that idea of a function to graphing a problem, or something like that. So that kind of decision tree logic exists in the platform. I haven't personally had the chance to use it yet because I haven't really developed for myself the intuition of how to structure all these questions so that every answer is meaningful in a certain way like that. But I know that many better instructors than I am are knowledgeable about that kind of thing. So this particular thing then, this particular class,
Sasha, can you tell us how long it took you to prepare this?
well, I will tell you that I had some help. Okay? The video clips actually go pretty quick because I have all my lecture notes. I've done those lectures. Well, I'm one of the sad faculty that has the yellowing lecture notes. I mean, they're not that different. It takes me maybe 15 minutes to do a 10-minute video clip because I've got to do some setup. I've got to think about on a piece of paper how it's going to lay out a little bit. It's kind of like making your little PowerPoint, right? And then I kind of barrel it out. And I haven't too often had to take multiple takes, but it's certainly the case that I've had to make multiple takes. What has taken the most time is then thinking about the kind of assessment questions I'd like to pair up with those. And, you know, if Eric Mazur wrote a whole book on it, it isn't a simple matter to do that. Okay, but I worked with some of the Quest team here, and point out Nathan Erickson helped me a lot here, or Jerry Shermer if you've met Jerry. And we went through the problem bank of Quest, and we tried to find some conceptual problems that would partner well with some of the video clips I did. And you know, it's been a couple months of work to get this all ready, I would say.
Can I ask the question a different way then? Let's suppose teaching a class that you've done lots of times, let's call that 1 unit of work. So during that semester, it is getting yourself, remember what you're going to talk about that day and do the problems and chat with students and stuff like that. Let's call that 1 unit of work. Is this 2 additional units of work or 50% of a unit or what do you think?
It's still hard to answer, and I'll tell you, and I don't mean to be evasive, but I'll tell you why it's hard to answer. The first time I've done the class, I'm still for myself trying to frame what all the material is. The second, I mean, this is the same parable we've often told ourselves. The second time, you realize all the things you should have done and all the key problems or stumbling blocks that the students are likely to hit. And so you teach it better the second time, but you still almost put in one more unit of work the
Yes.
second time you teach a class.
Yes,
I would say this is probably yet one more unit of work because
about one, okay.
you're putting yet that much more investment into organizing the materials into modular chunks so that every unit here has an outcome that you can identify
Okay.
and then ties to those kind of homeworks. You were gonna say something?
I would argue that it's even less,
Yes,
because as you do this kind of work, you are reassessing your own course de facto. So it means that when you go to lecture, you find yourself in lecture changing what you say.
okay.
You find a new efficiency because you've had to plot it out this way.
That's if you do it sort of in parallel with offering the class.
In general, that's what I would recommend that you do.
Gotcha.
You don't have to have this set before you start a class.
Mm-hmm.
You could actually teach a class, then while you're piddling along, say, what would I have asked here? And then, some of the questions that are on here, you could easily put into quizzes or exams that you had, and all you're doing is changing how you store it.
Excellent.
So there's nothing to stop you from creating this entire thing without students seeing it that semester or year,
Mm-hmm.
and actually having collaboration between several classes, in which you then get to see how other faculty members ask questions. So if nothing else, it's going to breed collaboration and efficiency and help reorganize your thoughts, and it's going to refresh how you think about a class. So if your class load is one work unit for that class becomes less of a unit because you now do better in that class.
The nifty thing that you've just said for me is doing it concurrent with offering the class. Because I think sometimes people have the model that they sit down and do this some semester when they are not teaching that class.
See that field where it says published? You don't have to publish it, and you can also take the whole thing and make it not available to students.
Mhm.
I personally found it beneficial to have done a good chunk of this class before I started teaching it. The novel experience for me is, usually when I'm teaching a class, I'm so in the moment of just trying to get through that week, that this gave me the chance to say, okay, my intro physics first semester has 5 important topics. I got to plan out that one of those 5 all in one go before I made a single video clip. I personally got to the point where I was starting to do PowerPoints, and then the PowerPoints would sort of unfold as I was speaking, and new lines of equations would pop up in the PowerPoint, and I just did that because it was easy to re-record if I made a mistake. But it was great to have this PowerPoint presentation that had like 60 slides, and that was going to encompass a couple weeks worth of material. Every little video clip was like 2 PowerPoints slides, and it would kind of unfold as I went. It was organizationally very helpful for me to have that opportunity, just a month of work where I could go and think about what that block of time had to look like and the next block of time. But I totally agree with you that if you're doing it in real time, you also get the added benefit of being able to iterate and make modifications on the fly. You can post a video clip in 10 minutes and then be ready to roll the next day. You don't have to do this weeks in advance.
Some people underestimate the collaborative value of it.
Yeah.
Most of us teach courses that are teach in some way or another. And if it's related, even if it's related to biology classes that are the same title, that cover similar material, offering to collaborate, let them see the questions you ask and you can see the nifty questions they ask. It's a lot faster and a lot easier.
To highlight your point, since I teach also the class that comes right after this, the sophomore level physics, I'm finding it useful now that I've done these little modules. If I'm in my sophomore physics class and I know full well that students don't remember something from freshman physics, I can just call up this other module and say, if you're rusty on this, you should go draw on that old thing. And I would think all of us could benefit from similar experiences. If our first year Bio 1 instructor is working with our Bio 2 instructor, they'll have some collaboration there, or even across departments, because as I mentioned before, if I could just have a whole bunch of modules on pre-calculus and calculus that I could draw on, that's a great resource too. I don't want to take all the time. I also want to have the opportunity for Cynthia Drake to talk a little bit about her course, because I think she's even further along than I am on anything like this.
Okay, thank you. All right, so I'm also using Quest. I'm doing something a little different. Well, I did something a little different last year, and I'm going to present it a little bit differently this year. But I was asked to take one of the classes that we teach here on campus, which is Chemistry 304K and 305, It's a non-majors kind of liberal arts chemistry class, and teach it as a dual credit high school class. And so I had the challenge to take what we normally do here in a lecture format and teach it to high schools across the state. So I used Quest.
They downloaded you?
They downloaded me. I never looked at it that way, but they did. They downloaded me. Let me just tell you a little bit about Cambridge first, then I'll tell you how we downloaded me. So this past year, we served 17 high schools. Of the 17 high schools, 16 of them were Title I high schools. And a Title I high school is one that has greater than 50% free or reduced lunch. They often have less resources than other high schools and less qualified teaching staff. So, and then one of the high schools was actually a private school in Laredo. So they have special challenges, especially when it comes to getting people downloaded into their classroom. Last year I had about 200 students across the 17 high schools. At the high school level, the class was called a technology class. It is not an advanced chemistry class at the high school level. An advanced chemistry class at the high school level would be an AP class. And that's sort of like our general chemistry here on campus, 301, just 301 I think, or 301 and 302? 301 and 302. So they couldn't call it chemistry, but there is something in the TEA called a technology class, which is what it was called, which serves as an advanced measure for high school, like advanced placement credits. On campus, like I said, it was the chemistry 304K and 305, which we kind of call liberal arts chemistry, or it's called chemistry in context. It doesn't serve to the science major as a credit, it's for non-science majors. Okay, so that's the class I was teaching. Oh, this is the book. We call it Chemistry in Context. It's a fun little book, sort of a survey of interest in chemistry topics. So the way we deliver the class is the Cambridge coordinator, and this year that was me, and next year that will be me, prepare the syllabus for the year and all of the assessments for these students. What I do is I work with the high school teacher. The high school teacher is the facilitator of the course, and I'm sort of the director or the coordinator of the course. So I'm really partnering with these high school teachers to deliver this curriculum. And the way I delivered the curriculum was via video and curricular documents delivered via Quest learning modules. Last year, we didn't have the learning modules available. This year, that's how I'm going to do it, and I can explain a little bit about that in a minute. All of the assessments last year and this year will be delivered via the Quest homework, quizzes, and exams, which I think most of you are probably familiar with. And on their end, all the answers are input via the web, and so we don't do the bubble sheet or anything like that. Everything is going to be put in on the computers in their classroom. And the questions are either multiple choice, or this year we're adding a new feature to Quest, which is called file upload. Okay, and what that is I can deliver a document to the students via Quest. They can work it out, and then they can upload it back to me so I can grade more critically. Okay, and so the way I work with the teachers, this is just an example of a 1-week plan. Some high schools are in 45-minute blocks of time. Some high schools run in 90-minute every other day blocks of time. So I broke the curriculum down into 45-minute blocks. And then for a particular week, week 2, I tell them what the goal of the week is. And then I tell them, or I advise to them what would be good to do each day of the week to get through the curriculum on time. And so this year, we're going to work through learning modules. So it's just learning module 1, 2, 3, 4 for that week. And then I always leave a little bit of time at the end for them to mop up or whatever. But the curriculum is being delivered via these learning modules. So then I try to make it as clear to the teacher as possible what to do. They're going to give learning modules. They have to start the homework because the homework takes time. And like the way Sasha did it was he showed the modules and then he gives the homework. But for these students, a lot of times you have to start on the homework a little bit sooner because they need help from their teacher. They can't do it on their own, and sometimes they end up doing that during their class time. So I wanted to show you an example of a Quest learning module. Okay, so this is the Quest page where you have all your courses. And so for this fall, I've set up 17 courses. So I'm the main instructor for the 17 courses, and then each teacher is my secondary instructor on all those courses. And then I have set up a template course right here. And on the template, what I do is I deliver the curriculum, the Quest learning modules, homeworks, and assessments one. I set it up on the template, And then the individual high school teachers come in and import those assignments into their own individual courses. So that's how we keep them separate. And I can't do it all at once because the high schools are all, they have different days off, they have different schedules, and so they have to have some flexibility in how they deliver the curriculum. And so, did that work?
Just a quick mechanical question.
Yes, sir.
You might have already answered it. These are high school students elsewhere who
Yes.
are directly accessing the class?
Yes.
These are dual credit students, so they are actually enrolled.
Okay.
We have more off-campus high school students than we do on-campus students using Quest right now.
The Quest is used all over the world, really, and so a high school can pay, what, I don't know, $100, $200, it's negotiable.
And evolving
But for
fees.
security purposes, now they get UTE.
Yeah, they get this kind of lower level UTE ID, so that's what all these kids will get, is like the lower level, not as high assurance or.
Is Quest a UT thing or more general?
Oh,
College
yes.
and natural
College
sciences.
of Natural
Yes.
Sciences.
Oh, really? I thought it was in your.
It's what Fred used to do, starting with the
Yeah,
OPT
yeah,
homework
yeah,
service.
Yeah, it's evolved.
It's rewritten. but,
Yeah, totally rewritten, but yes.
Yeah.
Okay, so this is my course, you saw what Sasha's looked like. Mine, I mean, the interface looks very, very similar, but I've just started setting this one up for this next year. And so I've got a pre-assessment where I'm gonna have the teachers give all the students a skill pre-assess and a concept pre-assess, sort of like what Sasha was talking about before, but for chemistry concept questions. Then the first unit is on nuclear chemistry, and so it looks a little out of order right now, but the, where's Shannon? Do you want to comment on this, or do you want me to keep talking there? Shannon is the Quest support person for this class this year, and so Shannon has helped me set up these learning modules. Last year, when I delivered the curriculum, I made videos, and I posted them on the chemistry department website. I made up assessments in Quest, and I also had sort of guided learning worksheets for them to do in class, for the teachers to do in class with the students. And I had the same kind of outline, 45-minute chunks, and I'd say, please watch this video on this day, watch this video on this day, now do this worksheet, now do this homework. And so I was telling them to do a lot of different things, which is a lot for a high school teacher who has 7 periods. Okay, and I'm just like one more period telling them lots of different things to do. And so what I learned last year by trying to teach this distance course was the teachers, I would put this stuff out there, they wouldn't necessarily go in the order that I suggested. They would give them things that, from a course development point of view, should have come later, earlier, and it was not for a lot of kids, it wasn't a nice, smooth presentation of the material. So this year, the improvement is, with the learning modules, I can use the Quest to control the delivery of the course. I can tell if the teachers have actually given the worksheet, the kind of the inquiry-based learning to the students, because I can see when they log in, I can see and I can force them to upload it back to me, and I know that they're going in the proper order. And so for me, it's a different plus to use this system because I can better control what's going on out in the classrooms. So the first learning module, for example, and that one is just a little introductory module where I'm using an animation. Like a lot of times in a textbook, there'll be a little sidebar and it'll say, oh, cool, look at this animation. Or the teacher will say, go look at this animation. And we know it's important, but the students, it's just another waste of time if you're not assessing it. So in this case, I have the animation, and I might need help, but I think I can do this without Shannon standing next to me. In this case, what you have, this is the inside the learning module.
Oops.
Oh, what happened? No. Okay, but that was like the highlight of the moment. I wonder what happened.
Something rebooted.
Oh, okay, there we go. It was just a chance to take a deep breath. Okay, so in this case, anyway, this is like slide 1 of the learning module, and it has instructions. Keep this window open this link, it's a simulation, and there's a worksheet. And so on the worksheet, they're going to,
So what happened is you're down to critical battery level?
yeah, I plugged it in, maybe this,
It's charging, but
it's too much stress.
it's all right.
Anyway, this is just an animation from that PHET site, and you, so what you do is you have the kids pull up the animation, and then there's a worksheet that walks them through the animation. Then they have to upload the worksheet back to me, If the teacher doesn't want to do that, well, we're working that out, but the next level would be for that worksheet to be in Quest also, and they put the answers in.
So you're saying the animations are still something they have to go get, as opposed to the animation playing when they're viewing the,
Right, so that's the next level of development. We've tried to, I mean, we're working on putting the animation right in Quest, but that is a lot of development, and like, to your point of how much time does it take to do this? So when I started teaching this class last year, I started preparing this class last year. I hadn't taught it in like 10 years, so it's a lot of work just to get the stuff together.
There are certainly animations that I think we all would like to embed directly in. For me, the most efficient solution I found, again, because there were some external animations I had available in the physics community, I made myself a little video clip of how to use the animation. I gave the web URL, and then I asked a series of multiple choice questions about what they would find if they did the animation and changed the variables and such like that. So
So yeah,
it's
while
still
you're
true that
talking,
we have to go
stuff
external, but I think we'll hear in a couple weeks about how mathematically it could be used in some of the problems.
So I've lost it completely because, well, oh no, here.
You're connected.
I know, well, it somehow I accidentally exited out of it, but whatever. Well, you get the point. The other thing I was gonna show you was that in some of them I have a video, and then I have some questions right after, similar to what he does. Some of them is an animation with some questions. Some of them is simply a big 45-minute activity that they're gonna do in class, and then they upload it. But the beauty of the Quest is that I can control the delivery and the assessment together. Okay. Shannon, did you want to say anything about how much time it takes to do all that and how much support we get?
Well, in Cynthia's case, she had presented me with, here's Unit 1, and she had all of the videos specified, so, and then the list of questions. And so when that's what she needs help with, that's really easy to put together. When I was working on the chemistry summer readiness materials, I had a list of videos that Deborah Walker or Vanessa made last year, but they had no questions to go along with them. And so then I was finding the questions that made sense to support this material. When you're doing that, it takes considerably more time. But that's the type of thing that in our Quest team we can help with.
They can help if you need help with the questions and stuff. And sometimes I'll write new questions depending on what I'm doing, and then they'll put them in for me. So that saves time on my end, so I can focus on the flow of the curriculum and the story I'm trying to tell, and then they can work on the mechanics in the background. So anyway, yes, sir.
Yeah.
No. So the value of the Quest and learning modules, you can control the pacing of the course, and you can control the curriculum delivery. And in my case, that's important because of the distance course. And one of the big things I think for my teachers this year that's going to be something I need to explain to them is the difference between a learning module and a homework. The learning module, in my case, is designed for independent or group learning to occur. So in that case, either some of them can be done as homework, and some of them need to be done in the class as a small group, but it's where the learning happens. And then the homework is designed to practice the new skills, knowledge, and the concepts and whatnot. So it's sort of like, for the students, a lot of times students themselves, especially high school students, don't know the difference between learning something new for the first time and practicing something that they've learned. And so that's one of the goals this year for me with the teachers in helping these kids get ready for college is to understand, what it is, where you are as you're learning something versus practicing something. And so that's kind of separated out in how I present it in the Quest. And I think that's all. Oh, I just wanted to show you the results from last year. This, last year I taught the 304K and the 305, most of the kids stayed all the way through. And so this is just the grades, how the grades came out. And so it's very similar to how the grades come out here on campus when this class is taught. 31 to 34% A's first and a big chunk of B's. And then I had more C's the second semester and a little bit more QDFs because they were checking out their seniors. But I didn't it's just Q. I didn't give anybody a D or an F because they're high school students. They're taking this as dual credit. And it's a challenging situation as it is, being where they are in their high schools. And so if they were failing, I forced them to Q drop so that they wouldn't come to college with a low GPA starting off. So that's just something special we can do with high school kids. But that's it. You're welcome.
Sasha, would I point out that Moon made a real good point that this is a good way to maybe come up with a new way of delivering some material, and as you teach through your courses this semester, you kind of line some of this stuff out, maybe start developing a little bit of it. And then the next time you go through, you have some basics done, and then you can run with it and actually to deliver to the students.
I think, Moon, also you made a good point. This is a way a faculty team can collaborate on a course. So many of us have good ideas about what a 2-semester course should look like or a 1-semester course should look like. It would be conceivable to have a group work on storyboarding an entire course and taking parts of it and developing chunks of a 1-semester course or contributing to each part of the course. And there's lots of ways to do that.
Physics, entry physics classes, right?
Oh, yeah,
You have a lot of, helps to coordinate with these.
absolutely. In terms of standardizing, to the extent that that's important, content across multiple sections of courses, that kind of platform can help do that. Because we have common assessments, common presentation material, and there might be different discussions that occur in the lecture class itself, but at least the presentation and assessment is the same. Your answer?
Yeah, just to be practical, there's a significant amount of learning curve involved for anyone who have not used a Quest, so I just wanted, on the optimistic cautionary note. But thanks to Sasha and the Quest team, I think it's really boosted the college support. I have never seen, I have compared several other learning and assessment systems, nothing comes close to what we have. And there's a lot of back-end work that goes on. Shane and Patsy puts it together. It came from physics, Fred Moore, and it evolved so much. And there's so much support being given there. I think you need to take best use of that.
Yeah, so let me just say a little bit because we have to kind of wrap up here for the day. So many of us are familiar with Shane Lewis and Patsy McDonald, who have been working on Quest for many years. But as faculty are considering implementing these tools for their courses, I want to also make sure that you're aware of the broader team that's now been constructed. Heather Van Lichten and Jesse Miller back there in the back are both mathematicians, but available for helping insert and manage content in Quest. Shannon Stokes back there is a chemist, and Nathan Erickson over here is a physicist. All of these folks are knowledgeable about Quest and about trying to construct learning modules and helping you with the problem banks and assembling course materials into a big format like this. And I think as you all get to the point where you might want to construct courses in Quest, I think they would all be glad to work with you on your classes. Next week, we'll hear from some other people while Brian Reeser is here in the back taping us. But the idea of making videos is probably a little bit daunting to some of us, and how do we do that? There's a lot of work that's been done in the college to sort of standardize on some formats and some means by which we can make videos. And most of us are good coming in and talking extemporaneously, so all we have to do is focus on that part, and they'll do the videography and the editing and so on to get it down to the point where it actually looks like something you'd be proud of being on the web. So after we hear about that from them next week, and I guess Jesse, you're going to lead that discussion, is that right? Then the week following, Heather will talk a little bit about how to use Mathematica for some of the assessment questions that would really expand beyond the kind of multiple choice that we've been doing. Because we've got now the capability of doing algebraic expressions. You can enter a polynomial or some elaborate expression and ask, is this graded correctly? And Mathematica will do the back-end evaluation of that. Or I don't know what other kinds of assessments that you're going to try to show us that in a couple weeks from now, but 2 weeks from now we'll hear about the Mathematica that's been built into Quest. Right? So with that, yes.
Sasha is, number one, I don't know that much about Quest. Does our little course go beyond Quest?
Does your little course go beyond Quest?
Our little Thursday meetings, will we talk about other tools other than Quest?
Do you have some specific ones?
No, because I just don't know about any of these things. Okay.
Well, what we try to do is take some of the best practices in terms of online learning tools and embed them into this.
Okay.
So mostly we're talking about how could you do things in Quest. If there are other things that people come across and would like to see developed as a resource, I am more than happy to talk about that. But I think right now, most of us have a very outdated view of what Quest is that homework server, and you just post up a bunch of problems, and I'm trying to get out a different teaching model that one can explore and what's currently available.
Thank you.
That's going to be the near-term focus.
I have a question. So if we're collaborating with someone like my colleagues at UT School of Public Health, as we think down the line for global health, would they be able to get in and see this in Quest?
Yes, still UT faculty, right?
Yeah.
All right, well, thank you all for coming, I appreciate that, and we'll see you next week if you can come back.